Every day, millions of people around the world fight against the silent battles of cancer and bacterial infections. Despite tremendous advancements in medical science, traditional treatments like chemotherapy or antibiotics come with their own set of challenges. For example, toxicity, side effects, and a growing threat of resistance.
But what if we could harness the power of nature to create a solution that is not only effective, but also sustainable and safer for both patients and the environment?
The answer is silver nanoparticles, tiny material with remarkable power to effectively eliminate bacteria and cancer cells. However, most current scientific methods still rely on toxic chemicals, posing risks to both human health and the environment. In contrast, green synthesis using plant-based extract offer a safer and more sustainable alternative.
Male papaya flower are a valuable medicinal source, rich in flavonoids, phenol, and organoids, compounds known for their antibacterial and anti-cancer properties. While papaya peel, seed, and leaf have already been studied, the use of male papaya flower in silver nanoparticle synthesis remain largely unexplored. That is the reason why we are here today. Our team introduced a novel method to synthesis of silver bio-nanoparticles using male Carica papaya flower extract for biomedical application.
The research project has two main objectives. First, to synthesize the silver nanoparticles using the extract of male papaya flowers. Second, to test their antibacterial activity and cytotoxicity against cancer cells.
The experimental procedure consists of three steps. First, preparation of male papaya flower extract. Second, concentration of the extract. Third, biosynthesis of silver nanoparticles.
The synthesis results were analyzed using advanced techniques. The first one is X-ray diffraction. So the XRD pattern showed clear peaks at characteristic diffraction angles, confirming the crystalline nature of the nanoparticles with the impurities. The second one is infrared spectroscopy. So the IR spectrum revealed key functional groups involved in the reduction of silver ions, confirming the active participation of the plant compounds. The final one is scanning electron microscopy. So these SEM images show the spherical nanoparticles ranging from 15 to 30 nanometers in size, optimal for biomedical application.
Next, the research team evaluated the antibacterial activity of nanoparticles against SA, PA, and E. coli at various concentrations 1, 10, 50, and 100 microgram per milliliter using the organic diffusion method.
At the concentration of 100 microgram per milliliters, the inhibition zones for SA, PA, and E. coli were 26, 25, and 34 millimeters, respectively. Based on the result, it can be concluded that the antibacterial effect is concentration dependent.
We also evaluated the anti-cancer activities of nanoparticles on gastric cancer and liver cancer cell lines. At the concentration of 100 microgram per milliliter, nanoparticles inhibited cell proliferation by 88.57% on AGS cells and 89.54% in HEPG2 cells.
Our study demonstrates that silver nanoparticles synthesized from male papaya flower extract possesses excellent antibacterial and anti-cancer properties. Compared to silver nanoparticles synthesized from other parts of the papaya plant, our silver nanoparticles show superior antibacterial activity. In addition, the cytotoxic effect on cancer cells was significantly stronger than that of conventional chemotherapeutic agents such as 5-FU.
Moving forward, we will optimize the synthesis condition to improve the yield and stability of silver nanoparticles. We will also conduct further studies in animal models to validate the efficacy and safety of these nanoparticles for clinical use. In conclusion, our study successfully demonstrated the synthesis of silver nanoparticles from male Carica papaya lineage flower extract using a green and sustainable method. Besides, the nanoparticles also exhibit promising antibacterial and anti-cancer activities, providing a safer and more effective alternative for medical applications. And that is all about our project, the synthesis of silver nanoparticles from male Carica papaya lineage extract for biomedical applications. Thank you for listening. See you again.